Hello again, internets. So I'm still working on the lathe upgrade, and I thought this would be the last video before I mount this guy up there where it's supposed to be. But over the weekend I made a stop out at Dillon's in Baraboo, Wisconsin, and literally dug another motor out of a snowbank. They're a surplus place. They have a lot of stuff and a lot of really interesting stuff. But I found a motor hooked to a gearbox out in the yard. They gave me a super good deal on it. I think I paid like 20 bucks. And the only thing I had to do was remove this weird output shaft that was pressed on. I don't know if it was pressed on, but there was enough goop and rust in there that I couldn't pull it off. So I actually had to turn down this coupling till I got to the keyway, pop the key out, and then basically mount this in a vise and slowly tap the motor off of it. So that was a bit of excitement. But anyways, today's video, which was planned, is to go over my RPM meter upgrades for the mill. So I'm going to have two RPM meters either mounted here or here, I haven't figured that out yet, where one will measure the speed of the chuck on the lathe, the other will measure the speed of the spindle of the mill. Now to do that, I'm going to put little metal flags on the back side of the pulley. So if this is your pulley, the flag will just sort of stick down, and then the sensor will sit over here and detect when that flag goes by. To mock that up, I made this little piece of hot death. So just a chunk of metal, proximity sensor, and a little strap. For the final version, I'll be using these little proximity sensors, which I just happen to have in my collection. But if you notice, there's a plug on the back for a cable. I have no idea what I did with the cables. So my next order, I found some Chinese knockoffs that I'm going to give a try, and hopefully it'll all work out. Else I'll just solder wires to it and call it good. So the proximity sensor goes over to this little meter. I just did some searching online for RPM meters, and I found this one on either eBay or AliExpress. Box is marked YM5135FR. Apparently they come in a couple different configurations, 5 volt, 7 to 12, or 12 to 24. I went 12 to 24 because that's what's going to be most of my control circuit. So pins 4 and 5 is your power in. I'm just using a 12 volt battery to test it out. Pins 1 and 2 are your signal in, where pins 2 and 4 are ground. So 2 and 4 are hooked together to the white wire, which is ground, to the blue wire, which is ground to the sensor. Pin 5, which is red, is hooked to brown to the sensor, which is power, and then also up to the battery in a second. And then pin 1, which is signal in, is hooked to black, which is the output of the sensor. So the first thing you got to do with these things is rip the back off. There's two switches, S1 and S2. They're used to set the mode and the divider. And this little jumper, I don't know what's for, but just leave it alone, I guess. You can find manuals for these online, but every one I've seen is a little bit different and none of them cover everything. So to start with, just plug this in, and first thing, hold down S2, which is this one, for about 5 seconds and let go, and that will bring up the mode menu. So they come, oops. So normally they come in mode 0, which is frequency. So hit S1, which is this side, to advance it to 1, which is RPM. I've totally forgotten what 2 and 3 are, but it doesn't matter. After a few seconds, it flips back to 0, 0. Now hold down S1 for about 5 seconds and let go, and you'll get this flashing display. This is where you set your divider. So if your output shaft has 1 flag in it, you set it to 1. And if your output shaft had, let's say, 4 flags around the circumference, you'd set it to 4. But anyways, you set those two things, let it sit for a few seconds, it goes back to the default menu like that. Now if I just spin this, there you can see it's updating. That spin was about 61 RPM. You let it sit for a few seconds, it goes back. So now, let's test this thing and see if it works. And not chop off an arm. So there's 164 RPM. seems reasonable for 5 hertz. Now let's get this up to 60. And 60 should be just about the rated frequency of the motor. So I'm getting 1800, which this motor was 1755, and I'm a little bit on the high side, so let me... So 1785 versus 1755 with no load, I think that's relatively reasonable. I did take out my Harbor Freight Special tachometer. Here, I'll just do it again. And the numbers were pretty darn close. So give me a second here. It's a little laser tack from Harbor Freight. And unfortunately there's holes in that strip. So there you can see 1796 versus 1794. That's pretty darn close. Now let's go up, and you can... There's the resonant frequency of my bench. So there we're at max frequency I'm willing to push this motor. And if I check the laser tack again, it is... I need to put a flag on here. There's just not enough contrast, so give me 1 second. Some blue tape to the rescue. Try that again. So 3597 versus 3592. And if we take the frequency of the motor, which was 1755, divide by 60, which is base frequency, and then multiply by our new frequency, which is 120, we get 3510, which is slightly below what we're actually getting, or both my meters are off, which is another good possibility. So now if I drop it down to 14.7, so 29.25 times 14.7, we should have about 429, and we're at 439. So again, slightly faster than theoretical, but I'm guessing that is correct. Now the last thing I want to test out is the response frequency of these in proximity switches. So at about 3,000, 4,000 pulses per minute, the sensor is fast enough to pick up and send out a high-low pulse, but I don't know where that maxes out. So now I'm going to set up with the motor so it gives 2 pulses per revolution, which would be the same as in my old set, as doubling the frequency of the VFD, which I don't want to do for obvious reasons. And we'll see just how responsive that little sensor is. So far so good. So that should be double, but we're still at 3,000, so I don't think it's keeping up. Or, yeah, so there's at 60, we're double. And as I increase the frequency, we see it plateau and then drop back down. So it looks like about 4,000, 5,000 pulses per minute. What is that in hertz? 5,000 divided by 60. So about 83 hertz is about as fast as this particular sensor can go. Now, one thing I know about these, the sensitivity is directly proportional to the gap. So I might be able to squeeze out a few more pulses per minute by readjusting my blades. Trick is get it close as possible without hitting. Okay, let's try that. Four, 5, 6, 7. So yeah, it looks like we can get, 240 hertz worth of sensitivity out of these sensors, or 7,000 RPM. My lathe, I never run over about 1,300. 1,400 is just not practical for how small this machine is. If something got out of balance, this whole thing would just topple over. And then the mill spindle, yeah, about $3,000 is all the more the bearings are probably worth. And again, I'm doing little stuff with little cutters, so it's not a big deal if I can't go as fast. I won't get as nice of a finish on certain parts, but so be it. If I went through here and replaced all the bearings with nice, real ABC6 or something else, I probably could get my speed up significantly more than 3,000, but I'm not doing that this round. So I think I've rambled enough. I just want to get this video done and out before I start tearing this apart. I may mount this just to get it out of the way and then make some sort of extension cord so I can test the other motor when I get it all put back together and get my bearings. So I'll probably make another video when I get the other motor set up for testing, but other than that, I'm done until I get my fuse holders in from China, which they're now off of vacation, so there's a chance they're on their way, and get everything figured out and mounted in there. I got a couple more parts I need to find, like ventilation fans and some odds and ends, but I've got a pretty good collection of pieces for this project ready to go for the assembly of the control panel. So, till next time, first thing you do is rip the back off. I have no idea what that jumper does, so I just left it alone. First thing, hold down switch 2, which is over, whoop, fire. And with that, I'm starting over.